Welcome, ladies and gentlemen. We're continuing our discussion of the formation of isoamyl acetate, but we're going to diverge to a sample midterm question right here. And this is the biggest question you will see on your midterm. It's more than 20 points, 18 points for this part only. And you'll see it's not a trivial 18 points. You got to do some work, but time well spent. So this gentleman here, Richard Branson, owner of Virgin Mobile, Virgin Airlines, and I'm told that he was on Shark Tank. I didn't know that. He's offered you, and we're going to change this right now because I was told earlier that in the other video there was a huge profit, like insane. So I just guessed that number. So we're going to go to 2 million. Change 200,000 to 2 million. 2 million. And that makes it closer to what you're going to see on your midterm anyway. It will be an offer in the millions on your midterm. So guys, I'm just telling you now, you better know what a million is. The word, what is the number? Please tell me. I like 10 to the 6. That's a good way to remember it. 1 with 6 zeros. Yeah. Okay. So we edited our question. Earlier we discussed that. We're going to do research of that and tell me what, always please start with the acid. What was the acid we have to look up? Myristic acid. An 8-ester comes from a ic acid. See that? An 8-ester comes from an ic acid. Oh, keep the T. I can't keep the T. It won't let me. There we go. And we can go bigger. We're going to zoom for the room a little bit here. And okay. So myristic acid. And what about after you do that? Well, you should think about your alcohol. And what's your alcohol there? Isobutyl alcohol. I got stuff in the way here. Isobutyl alcohol. Okay. Alcohol. Okay. Myristic acid, isobutyl alcohol. So we're going to go off screen. We're going to do some research and find all the data we can on myristic acid and isobutyl alcohol, and we're going to come back. We're back. We did some research, and here we are. We found myristic acid. So can everybody get to page 1955 and tell me one thing first. Is myristic acid a liquid or a solid based on the information you have in front of you? It's a boiling point, so it's a liquid. I don't need a boiling point for this exercise, but for liquids, I need 3 things. I need a formula weight for everything. Now, guys, somebody asked me last week, I need to find the molecular weight, but I can't find it. They call it formula weight in the Aldrich. They're the same thing. For us, they're the same thing. So what is the formula weight? Just read the number for me, please. Myristic acid formula weight? 228.37. Do they give units? If they don't, I want you to give me units because formula weights always have the same unit. Grams per mole. It's a liquid. I also need its density. Unless they're selling it by mass, but I don't think so. I need the density. Oh, they are selling it by mass? Let's talk about that when we get there. Generally, you need the density of a liquid, so give it to me. 0 point? No? It's under D. Okay. You sure there was a boiling point? Oh, there's a melting point. Oh, it's a solid. Is the melting point above room temperature? Yeah, it's a solid. Okay. That also has a melting point. So you don't need densities for solids. So give me the, I need the price. Now, ladies and gentlemen, you're trying to make money. You need the best dollars per mole price. They don't give dollars per mole, but you guys are smart kids. Some of you are closer to smart adults. You're all adults, okay? I shouldn't have said that. I'm sorry. I'm just getting older. Everybody's a kid now. So, bulk shopping, you buy a lot, and generally you get a deal, right? So you give me what you think is the best deal on that list. You don't know it yet, maybe. The prices are on the right, and there's multiple entries. And the bulk ones are always near the bottom, right? So what is the last entry there? How many dollars and how much are you buying? 73 what? $73 on the button? 10 for how much stuff? 500 grams. Good. We're buying it by the half kilogram, right? There's no cheaper price. So what's the one above it say? For 100 grams for how much dollars? $40. You're spending like more than half the money and getting only 1/5. That's not a good price. I think you found the best price. So solids, I only need formula weight and price. And liquids, please go to page 1908. I'm going to need the whole shooting match because that's a liquid. Once you find it, I'm going to need its formula weight. 74.12 grams per mole. And density, 848 grams per ml, 43 grams per ml. And the best price. Now, are there multiple entries for 2-methyl-1-propanol, like multiple lists, or just one? This is good. She brought this up. She said there's one with a carbon 13. Please, we don't use any weird isotopes in this class, and those are always way too expensive anyway. So if you see C13 in the name, don't use it. If you see anything with deuterium in it, don't use it. The prices are wacky anyway. They're ridiculous. So go to the entry that says 2-methyl-1-propanol, nothing special. Probably the bottom price. What is the dollars? 102.5 for 4 liters. Oh, I do want to buy the 20 liter. I'm going to write them both down. How much money for 20 liters, please? 348 on the button for 20 liters. You make a decision for me. You're buying 5 times as much stuff for less than 3 times as much money. Which one's a better deal? This one. Got it. Get rid of that one. You did some bad shopping there. You'd lose a point on your midterm. It's okay, guys. If you do bad shopping, you lose 1 point. That's it. 803. I was having trouble listening. Okay. And I think the 3 entries we need are there. Now you're going to move on to page 2545. Paratoluene sulfonic acid. If it's a solid, I need the formula weight and the price. And I believe it is 190.22 G per mole. And the price, oh, don't worry about the grade. It's all about the price. She's noticed many purities. Look at all the purities and find the one that has the best price. So you got multiple lists to choose from. It'll generally be the one that sells you the biggest amount of stuff. I mean, that's a clue. Oh, that's a lot of good stuff. So how many dollars for the 15 kilograms? $23.50. That's some cheap stuff. 223, still cheap stuff. And 50 cents? Because 15 kilograms is a lot of stuff. Okay, that's our research. That's good. And I knew I had to buy paratoluene sulfonic acid because in my instructions, it says I need paratoluene sulfonic acid. Okay. Less obtrusive gray arrow there. They sold us the monohydrate. We'll live with it. Okay. So we have to do what they say here. Figure out how much stuff I need to make. You are making the stuff to sell to Mr. Branson. You better make as much as he wants. He's the customer, right? So you're not going to plan on making this amount. You got to plan and figure out what the theoretical amount should be. What am I talking about? Okay, this is the actual yield right there. This container, that size, is the yield. We always plan on making more than our actual yield, right? Because there's no such thing as a reaction that has more than 100% yield. In fact, this very reaction here has a 72.6% yield. So I need the volume of the vessel first. And I have to use pi r squared times L. Now, ladies and gentlemen, if you use meters per cubed as a volume, good luck. Do you have any concept of meters cubed? Do you ever use meters cubed in lab? Do you know how big a meter cubed is? Give me your a household object is a meter cubed. Yes? What object you have at home that is that? I can't even, on the video, I got to go full length and length with height. You have one in your basement. Furnace is a little bigger than that. Washing machine, dryer. Guys. So I've had this statement said many times, and that you need to talk to those people. They'll say this, it's crazy. They'll say it. They'll say there's 100 centimeters cubed in a meter cube. 100 centimeters cubed, that's adorable. Like this is 400 centimeters cubed. Your washing machine's smaller than this. That's what you said on the midterm. But there's 100 centimeters in a meter, Dr. Whitaker. Oh, but it's a volume. It's 100 centimeters by 100 centimeters by 100 centimeters. There's 1,000,000 centimeters cubed per meter. Do you want to memorize that? Guys, do yourself a favor. Make these into centimeters now. Centimeters are usable. Okay, so talk to me. 18 meters. I don't want meters. What do I want? How many centimeters is that? It better have 1 and 8. 18 meters is how many centimeters? You put 2 zeros, right? And you put the C. Okay. That's the L. What about the R? What's the R? 2.9 divided by 2 times 100, right? What does R mean, ladies and gentlemen? This is not R when it's the whole diameter. Radius is half. And guys, you're stressing. You're stressing out. I can tell you're stressing out. Stop. You're not doing a cylinder on your midterm anyway. You're doing something simpler. I'm not going to go give it all away, but simpler object than a cylinder, I wonder. Okay, that's all I got. Okay? So, but just don't go with this thing. What's half of 2.9? 1.45, and you want to go 1.45 times 100. What do you got? 145, get rid of the dot, and you got to square it, right? Parentheses. This is hard. This is where ChemDraw is going to slow us down. Squared times F10. Good. And that's, you got to throw a pi in there, right? Pi. You don't have to use pi in your midterm, so I'm not going to stress out. Okay? It's pi time. I need calculators out. I should have warned you. I'm going to stop the video. Stop share. Pause video. All right, we're told it's a very big number. This is not a surprise to anybody, I don't think. And she's going to give me the number right now. It's not true. Oh, she doesn't have the number. That's pi time.
Okay, 118.
118.
893.
893.
574.
574. Centimeters cubed, correct? Do the units work out based on what my math? Centimeters in parentheses squared times centimeters. Good, I like this. Good. Now that's actual yield. I'm going to write that there. That's actual yield. Actual yield. You actually have to make that. What about theoretical yield? What's the equation for actual and theoretical and percent? They're all in there, right? Okay, percent yield equals I'm trying to get what I need here. And then paste percent yield equals, let's see, actual yield over theoretical yield times 100. Is that right? Yeah. Yeah, I picked the wrong arrow. What's a good short form for theoretical? Theo? Theo's pretty good. I like that. What's your guy's name? Yeah. We'll go all the way. And it's not a percent yet. What do I have to do? Times 100. I can't get my orange line. Not okay. Oh, I got the actual. Times 100. Times 100. I got to reorganize that. No, that's the question is, what is the theoretical? That's what you have to plan to make, right? So that's good. So reorganize for theoretical yield by itself. Theoretical yield equals.
Need those orange lines?
No, those are for me just so I don't have to keep drawing them. She asked, do I need the orange? They need the orange line. Theoretical yield is equal to, bring that to the numerator and bring, let's see, that's going to go denominator. And let's see, I have theoreticals up here, percents on the bottom, actuals on the top still. Yeah. Orange line is unattainable. That's too big. Times 100, I don't have room for. Kendra, disaster. You like when a teacher has to slow down though. Times 100? I can't do it. I don't even know where my equal sign went. It's a nightmare, everybody. Now it's on an angle. Can somebody work it out for me? There's supposed to be an equal sign here, and I can't get it. It's hidden. Actual is your big number, right? Percent yield given in stipulation number 1 above. That's one way to say it. Or you can just take the big number you had, multiply by 100, divide by 72.6. And it'll be a bigger number than your bigger number. But not I mean, it'll be in the ballpark. Now I get the equal sign. All right, I brought an equal sign. It's going to be same number of digits. My guess is in the 140s. 60 is my new guess. All right, say all the numbers loudly. 1637652.534. I think we'll just go with 0.5. Didn't get bigger. That's a lot smaller. Multiply by 100. 5, then what? Does what I have on the screen right so far?
Okay, 1637652.534. 893.4.
Okay. Now we got a percent. And I don't like the 0.4 because it took me over the edge. Good, I got rid of it. I think we have enough sig figs, trust me. Okay, so you got to plan on making that. Okay. Here's my, we're kind of wandering over here. That's centimeters cubed. How am I going to figure out moles? Ladies and gentlemen, it's all about moles. It always is about moles. This is chemistry. If you're not going to moles, you're not focused. I need to go to moles, but I don't have enough information to go direct. Yes, I have this. 1.212 grams per centimeter cubed. Oh, where did that come from? cm cubed and milliliters are synonymous with each other. If we don't know that, we have to learn it. We have to learn that. Every person in this room must know centimeters and cubed and milliliters are the same thing. I am not going to say it anymore. Okay. I wanted a times because that'll get rid of centimeters cubed and give me grams. It's great. Going up again. I need the number. It's going to be over 2. Maybe. Is it over 2?
Yes,
240. 561. 127. There we'll go 8. There we go. We'll go decimalist. Good. So, we need the ester, everybody. Uh-oh, we cannot move on if we have 2 students with different numbers. We're going to pause. All right, ladies and gentlemen, we need to figure out how many moles of ester that is. What other information do I need? Guys, when you have grams and you want moles, I mean, I'm like Pavlov's dog when I hear that. My eyes go towards the periodic table. You know what I'm saying? When I have grams and I want moles, that's what the periodic table's for, right? But we don't have the molar mass of the ester. Remember, you're making an ester. I need to figure out the molar mass of the ester. Ladies and gentlemen, there's other videos where there's 2 esters in the same molecule. Yours is not one of those, so that's why we're making this video. Yours will be a 1-to-1 stoichiometry to cut you a break. So you've got 1 alcohol. You've got 1 carboxylic acid. You know the formula weight of each one. Tell me how to calculate the formula weight of the ester based on information that's on the screen in blue and I guess burgundy. Add up the 2 formula weights and don't forget it's a condensation reaction. Subtract water, 74.12 minus, my toolbar's in the way. No, that's not. Minus 18.02. What's 18.02 represent? Water's molar mass. And somebody please do that for me. I'll ballpark it. We got 302.5-ish minus 1884. What? 284? 284.47. Keep all those. Thank you. Now I can go to moles of ester. Back to theoretical yield equals. Things on my. Okay. Theoretical yield equals. All right, we've got our new number, this many grams. Times 1 mole for what? How many grams? 284.47. I'm just trying to make my page a little bigger. It already is as big as I can get. Okay. Okay, why not? Do it this way. And I need a nice smaller number. So you're dividing this by 284.47. That's what that is. All right, everybody, we have our theoretical yield of ester in moles. Remember, ester. This is the stuff you're making for the guy. Okay, now we're going to price out each of the chemicals based on that many moles of ester and the stipulations above. The stipulations above, we already used the 72.6% to figure out the theoretical yield. We have to use 2.75-fold excess of the cheaper reactant. Guys, the only numbers that mean anything are dollars per mole. We don't have it yet. That's our next job. There's two reactants, alcohol, carboxylic acid. I need to know which one's cheaper per mole. You have all the data you need. Let's do $73 for every 500 grams. How do I get rid of the grams? Because I need that to be moles. Don't forget, it's a denominator right there. Times something grams per mole, right? Which is 228.37 grams per mole. And when you work that out, grams disappears, and it's going to be dollars per mole. You're going to work that out for me. Dollars per mole. And it looks like divided by 1,000 is 0.07. Double that, 0.14. 10%, 300-ish? No, 30-ish? I give up. Sorry? 33.38? Give me a few more decimals. So we're down to 6.9, 7.69. Okay. Dollars per mole. And let's do the blue. A little more work on the blue. Quite a bit more work. That's per 20 liters. We got to go to milliliters so we can use the density, right? Remember, liters is on the bottom, so I need to cancel it on top. There's 1 liter for how many milliliters? 1,000 milliliters. So now you've got dollars per milliliter, correct? And I need dollars per gram, so I can go to dollars per mole. So how do I get milliliters to be grams? Grams on top, milliliters on bottom. What number goes in front of grams? It's right above on the screen. I want to get rid of, oh, you're right, I want to get rid of milliliters. Thank you so much for spotting that. It's hard when you don't do numerator denominator, isn't it? Milliliter per 0.803, 0.803 G. And that's going to be dollars per gram now. And I want dollars per mole. So I need grams on top to get rid of. And moles on bottom. And that's the molar mass, 7412, correct?
Where'd you get the 0.8?
Right above. She asked where I got the 0.803, and it was the density right there. And I'll pause. Stop share. All right, ladies and gentlemen, I forgot when we paused to come back. So here we are. We did the math. This one is by far cheaper per mole than this one. So which one's excess? This is factor number 2 for choosing an excess chemical, by the way. Right here. What was factor number 1 for choosing the excess chemical? Previous video, the one that's easier to get rid of. Factor number 2 for buying an excess chemical, the cheaper one, dollars per mole. You don't want to waste money. Excess chemical, you're wasting chemical, right? You want to waste expensive chemicals or cheap chemicals? Please, cheap. So this is which one, excess or limiting? It's a lot cheaper. Excess. Therefore, what's the other one? Limiting. Oh, caps, I guess. Okay. Right, justify that. I'm sorry? That was factor number 1 from the previous video. Why do we choose acetic acid to be excess in today's experiment that's in the hood? 1 was easy to get rid of. And 2, coincidentally, it's a lot cheaper than isopentyl alcohol. That's experiment 8B. Same story here. This one's a lot cheaper than the other one. The alcohol in this case is cheaper. Sadly, it's not easier to get rid of. We're going to sacrifice that. But this is on paper. We don't have to worry about how easy it is to clean up. Okay, so what about buying stuff now? If we're consistent, can't we make our catalyst into dollars per mole too? And that will save you time later. Okay, I shouldn't have asked it as a question. I'm stating, do dollars per mole on your catalyst too. Okay, so I need my dollars per kilogram because they're selling big amounts. He asked, why would it be in kilograms? Oh, it's a solids. So you sell solids, big amounts of solids are in kilograms, big amounts of liquids are in liters. No, because they're not being nice. Okay, times something that gets rid of kilograms, and bothering me, it should be a capital K. And let's see, kilograms have to be on the top. So there's 1 kilogram for every 1,000 grams. Now we got dollars per gram. We can go to dollars per mole direct, live and direct, times 223 dollars, 223.50 for how many kilograms? Wait, we already have that. What am I doing? I got to get to moles. I'm sorry. I'm at grams. Do we agree? But it's in the denominator. Do we agree? Okay. So I need grams on top. How many grams per mole? 190.22 grams per ml. OL. Oh, don't say ml. And work that out for me. Divided by 15, divided by 10, this one, 2.3, half of that. Oh, I don't even want to try. I'm going to pause. Oh, she's got it. No, okay. So I got to divide this by 15, then divide that by 1,000, and then multiply the answer by 190.22. It's pretty cheap stuff. That's good. 2.83. 2.834. 2.834.278. And that's dollars per mole. And don't use that for any decision making, people. It's the catalyst. You're not trying to price anything based on the catalyst, okay? It's just, it makes sure doing the total easy at the end. If you have dollars per mole, total's a lot easier at the end. Okay. So what are we doing here? Do you want to deal with the excess reactant first? We need to make this many moles of ester, right? I'm going to try to use my orange lines now. Just remember, that's moles ester times 1 mole. The excess is alcohol, right? And that's per mole of ester. So what's going on there? How did I know that? I promised you something. That's how I knew that. 1 mole of alcohol per 1 mole of ester. Where do these numbers come from? I told you the stoichiometry. Oh, gosh. 1 mole ester, 1 mole alcohol reacted for 1 mole of ester made. Good. Now that alcohol is the excess chemical, right? How much excess? The stipulation at the top of the screen. 2.75 fold excess. What's fold mean? Okay, here's an example of fold. I have a recipe that makes a dozen cookies. I want to make 100 dozen cookies. What do I do to the recipe? Multiply it by 100. So every ingredient is 100-fold. It's the factor. It's just a factor, a multiplier. It's a number. I want 2.75 times more than I need. Okay? And now dollars per mole. Copy. Times. So it's going to be a big old number, please, and it might be approaching the million. It'll be over 1 million. Yeah. I'm worried that we should have made our offer a little bigger already. That's okay. We might take a deficit. Mr. Branson will have some harsh words for us. Is it 3 million? 072 839. So 40. Nearest dollar now. Dollars are fine. It does round to 840, right? Yep. Okay. So right now you tell them to take a hike, but no, do the calculations, okay? So I'm just using this because I like the format. But now we're going to talk about the acid. There ain't no 275 in this calculation. You know why? Because that's the limiting reactant. Straight up, I need moles ester times 1 mole acid per mole ester. And the dollars were here. No, here. There they are. Keeping the color scheme. Don't do the math, please, unless you have that number in there. I don't like blue. Well, I do love blue. No, it is not the excess chemical. Do not multiply it by 2.75. 23295 619. So 620 millions again. Do we have a green? No, that's too much. Is it 23 million? Wow. Wow, it's an expensive chemical. That makes sense then. Yeah. Should we make it a better question now? You know, because that's 25. Let's just make it 25 million or something. 25 million. $25 million. Yeah, a house. Mr. Branson does have a house that's probably that expensive. Yeah. Okay. Yeah. We're still taking a deficit, right? Yeah, but at least the numbers are like not ridiculously in Mr. Branson's face. Yeah. Okay, so this one is going to now be for the catalyst. I can't believe we're almost getting this on a page. Not 1 mole cat. How many moles cat per how many moles ester? Where did that come from? And it's not 1. It is 1.5 per 100. Where the heck did that come from? You're told you have to use 1.5 mole percent catalyst. That's relative to the limiting reactant, or the theoretical yield is what I should say. So 1.5 over 100 is a fraction that represents 1.5%, right? Yeah. And that's the dollars here. It's different. Copy. Paste. Equals. So you're not spending a lot on that. Oh, I forgot a dollar sign here. 29, sorry, dollars. 29663. Point. So it stays there. Okay. And I need a total. Give me the pink, the burgundy, and the blue. 26 million and something. $26 million. I just looked at those first two and got 26 million. They're thinking of bump that. What do we got? Blue, burgundy, pink. Ready for the big finish? Whoa, yes. We have a total of $26,398,000, $123. And we got to figure out what to tell Mr. Branson. We edited our question to make it a $25 million offer. If my computer lets me see this. I don't think this gets up in the recording anyway, but there it is. $25 million is your offer, right? Can you make that into a number for me, please? Don't write 25 million. You can't do math on a calculator. How many? What am I putting after the 25? 6 zeros. Okay, now.
You should like round it down.
That's the offer exactly. That is the offer by Mr. Branson. No, it didn't say that number, but we edited it to say that just now. $25 million was offered. What are you spending? Minus 20. I'm gonna copy paste. Yeah. So that is the. Well, we don't write dollars. Yeah, that's a deficit, right? Now, here's the deal, everybody. We want to figure out the percent profit or percent deficit. It's the same equation every time. How much money you're being offered, subtract how much you're spending, divide by how much you're offered, just the 25 million down there, times 100. And the question is, what percentage of 25 million is 1.654 million? Yeah, negative 5 point. Give me one more decimal. 59%. And that's a negative. The negative is actually a fact. That means a great deal. If it was positive, it would be a profit. If it's negative, it's a deficit. Deficit. Branson says what? Or the British equivalent of take a hike. I don't know what that is. Okay. Oh, there's some saucy ones the British have that are pretty priceless, but I'm not going to say any of them. Okay. All right. So there you have it, everybody. I think that's the last part. We kind of did it above. Yeah. Yeah. Take a hike. You is Branson, right? Oh no! Wait. We say take a hike. Yeah. He's the guy offering. Oh man, we says no. That's not English. We say take a hike, Mr. Branson. I forgot who was doing what. Well, he is pretty good about that. He would probably talk to you. Okay, I think that's it for this thing. Okay, everybody.